Section 3.3, we are studying measure of position. So we have studied the two sections so far, right? The first section, we are trying to study what we call like the central tendency, like the middle point, the central point, right? We have 4 different angles to measure that. And then the second section, we are studying the change. After you measure the central, the average, right? Can we measure in terms of the change of the data sequence? So that's the variance, the standard deviation jump in, right? So 3.3, we will continue. We will continue to compare data sequence using the average, using the standard deviation together, right? So this time here, you will see the situation we are having is very unique. And actually, in reality, you see that. Now, we have student 1 that is in the math class, right? Average 65. The class average of that math class, 50, right? So we know that the students is better than the average. We know that, right? Another student is in a biology class. So 30, got a 30 points. The average for that class is 25. Everybody? So we can see both students, they are better than average. But the concern, the trouble we have here is, they are in different class. If we are trying to ask ourselves, which student is better, right? So you can see that it's not that intuitively easy to answer that, right? So, if both students, they are in the same class, they are both in the math class, that's easy, right? But now they are in a different environment, everybody. That's actually what we see in the reality, right? Usually people in different environment, and then how do you evaluate, right? How do you kind of ranking them, right? Different environment, but you still want to compare, right? So in this case, we introduce this Z-score, or we call this standard score. Everybody, you will hear this a lot in our stats class or later on in reality. Some people, you may hear some people talk about like Z-score. That's the calculation we are using. So how do we calculate Z-score, everybody? For example, for the math person, right? How do we calculate the Z-score, Z1? So we are going to use the average, that person X, right? That's in the formula X. So how many points? 65 minus the average for that class, 50, right? Divided by the standard deviation, everybody, sigma, if we are talking about the population, or S, if you are talking about sample. In our case here, it's a sample, right? It's a 1 class. So it's 10 in the denominator. So we got this 1.5. That's what we call Z-score, right? The standard score for the math person. And then for the biology person here, we can do the similar calculation. That a person got a 30, right? Minus their class average for that biology class 25 divided by standard deviation 5. So we got what? 1. Everybody? So how do we compare them? So we are trying to see which number is bigger than which student is better. So how do we understand that, right? So we can understand that everybody is the one that we just learned earlier, right? Say here is the average, right? Is the average. So even though those two people, they are in different environment, right? So we can still have this concept, this idea that like the math people here, math person here, right? The Z-score is 1.5. So how do we understand this 1.5? You can understand this 1.5 as like 1.5 standard deviation above the average. So say here is the 1 standard deviation and another half. So that's like the math person is like somewhere here, 1.5 standard deviation above, right? Now, where's this biology person? biology person, you got 1. So it's like 1 standard deviation above is like here. Now you know which one is better, right? So we know the math person is higher, that math person, student number 1, rank higher. So in the beginning, we are in a situation like apple to orange, right? So later on, we convert everything is apple to apple comparison, to be fair. So that's the concept of Z-score. Everybody, I hope that's you got what I'm trying to explain here. Okay. Now, second part, we are going to learn something about percentile. What I mean is, say if we have, 100 data points, that's easy. And we want to break those data, right? And put them in order, right? From low to high, high to low, either way, right? And then we want to break them into 100 equal group. Everybody, that's easy, right? So each one will be, you can easily find out which one is the top 1%, right? Or like 99%, right? Which one is the bottom 1%, like that, right? So that's what we call like a percentile coming. Is to help us understand like the position, right? When you break the data into 100 equal groups. Okay. The trouble here is now, what if you don't have 100 data points, right? Say you have like 10 data points. Like this example here, like 10 students here. So out of those 10 exam scores, right? We want to find out, like, I just randomly choose one person here, like for this one. The person got a 12, right? So we want to find out what's the position for that students, right? Is he or she in the like top 20% or is in the bottom 30%? Like what's the percentile for that students, right? So how do we calculate the corresponding percentile given those information? Okay, so what we are trying to do here is using the, using the formula. Everybody, I need your attention here. If you are trying to, if you care about homework, right? If you care about the exam, right? So first, what do? We try to put the data in order. Everybody, try to sort the data. In fact, it's the most common technique, like when you deal with reality data, right? When you sort the data, you will see that more clear, right? So first, we sort the data, usually low to high, right? So now we find out where is this 12, we got this person here, right? Okay, now in the formula, the percentile calculation formula, everybody, how do we calculate for this person here, what is his position or her position, right? Out of those 10 people, right? So the formula here is given by number of values below that person, right? So we are trying to see, here's a 12, right? How many numbers below 12? We have 1, 2, 3, 4, 5, 6, right? We have 6 of them. So that means with this bracket here is equal to what? How many number of values below that 12? We have 6. 6 plus 0.5. You see that here, everybody? Right? 6 plus 0.5 divided by the total number of data points. How many? We have 10. We have 10 data points, right? We have 10 data points. So divided by 10. So we got 65%. Everybody? So that's the position for that students out of those 10 people. So now we can understand that person is like in the 65%. That's like A, B, C, D. Like that's in the D, right? It's not that good, right? Not in the top ones, but it's not that bad. F is right. It's like around that D range, right? So if that's the like class grade, right? So that's the idea in terms of calculation for the percentile. I hope that explain the concept. How do we calculate the percentile? Now, another example here, I want you to pay some attention here. This is a little bit of tricky example here. Okay, so what's happening here is, in the previous example, you are given, I mean, this number of 12, right? So and then you ask people, like for this person, what is his position or her position? What is the corresponding percentile, right? So you are given the number first, right? And you try to find out the corresponding percentile, right? You are going this direction. Now, what if they are going backwards, right? So what's happening here is now someone asking, tell me which value corresponding to the 25th percentile, right? So in other words, they are given this percentile number first, 25% in our case. So in other words, in the formula, we know on the one side previously, right? That's the percentile calculation. Like previously we did a calculate, that case is 65%. Now, this part is actually given 65%, 25%, right? Now, we plug everything into that equation, okay? Divided by 10 because we have 10 people plus 0.5. Everybody? Someone will have a question. Why we got a 0.5 here, everybody? 0.5 here, the purpose of using that is to separate. So I have been using a different textbook, most textbook using this plus 0.5, okay? Some textbook, they say they don't use that, okay? So I prefer using this 0.5 as a kind of a separation, okay? So in our formula, we are using this 0.5 here. Now, the part you may get confused is like, what's this part? Is that right? So it's like you can consider as like something altogether, okay? Right? Like some big piece, like Z, for example, or I mean, Z actually is reserved for the Z-score, right? So in statistics, by the way, that Z, whenever you see Z, is a reserved, right, letter in statistics, okay? Similar to that in mu, right? Those are the very special letters, okay? Now, how do we solve this equation here, everybody? How do we solve this equation here? We consider this is like one piece is considered that way, right? Consider this is as, let's see, like say Y like that, okay? Like now you got this Y, everybody, Y plus 0.5 divided by 10, right? And is equal to what? 0.25, that's 25%, right? I think someone might still get confused why we add this 0.5 here, right? Everybody? So why we add this 0.5, you can say in the formula, we always have that 0.5. Okay, that's one explanation. Another explanation is when I say this 0.5 will help us separate those data points. So in this case here, you will separate those, like you got a 65%, right? You don't have like 60% or 70%. Like this 65% is you will not mix with other cases. Okay, that's the one I'm using here. Now, let me see. So how do we solve this equation here, right? How do we solve this equation here? So in the case that we have, is that like high school algebra, is that right? Everybody, another way to understand like why we prefer to have this 0.5 here, if you think about that way, right? If, for example, you're talking about 20, right? You're talking about 20 here, right? So how many number of data points below 20? You have a line, right? If you don't have this 0.5 here, you got a line divided by 10, you got a 90%. But actually this one is like what? It's the hardest one, right? Ideally is what? It's 100%, right? So it's not 90%. 90% is not accurate, is that right? But so we are reduce that a little bit. We don't say 90%. How about we add in 0.5 here, say 95%? We still don't have 100%, but we are getting more close to that 100%. That's the purpose of adding 0.5%, 0.5 here.
Professor?
Yeah.
So, am I understanding that the 0.5% is
0.5?
Yes, sorry, 0.5 is for the intention of getting as close as possible to the 100 mark, because this whole topic is about percentile?
Yeah, you can understand that way. Yeah.
Okay.
Yeah.
All right. Thank you.
Now, yeah, back to this question here, how do we solve this, right? I mean, counting on your high school algebra teacher, right? So what do we do? Both sides multiply by 10, right? So you got a y plus 0.5 equal to, let me see, 10 multiplied by 2.5, you got 2.5, is that right? 2.5. And y should be equal to what? 2. Is that right? Y should be equal to 2. So in that case, you see that this whole thing here is equal to 2. What does that mean? That means there are two numbers. That 2 means what? There are two numbers, number values below this x. Because we are trying to find out what's x, right? 2 means there are two number values below that x. So everybody back to this data sequence here. Which number? So there are two numbers below that number. Everybody? That must be 5. Is that right? So there are two numbers below 5, right? I mean, if you check 6, how many numbers are less than 6? You have a 3 here, right? How many numbers less than 3? 1, right? The only number that has two numbers less than that number would be 5. That's the only choice. So we know, what's that number? That number must be 5. So we know 5, that number here corresponding to 25th percentile. I hope that's clear in terms of the backward. Everybody, this is very, very important. I hope you understand how do we do the backward calculation, right? Usually backward is more difficult. Okay, so that's for the percentile introduction here. We had formula in terms of given you a number, help me find out what's the corresponding percentile, or given you a percentile, help me find out which number would it be. Okay, so both ways. Make sure you feel comfortable for that. Now, decile, that's say, if we are trying to break the data into 100 groups, right? Someone say that's too many, right? Can we see a little bit less, right? Yes, we can break that. For example, how about 10 equal groups, right? So you have like 10%, 20%, 30%, and so on, right? Each of them, it is also a percentile, right? But we have a spatial meaning for spatial concept, right? A terminology, we call this decile, okay? And then someone say, I feel like 10 equal groups is still too many. Can we reduce to like 4 groups, 4 equal groups? Yes, we can do that. We can break that into 4 equal groups, 25th percent, 50, 75, 100. So that'll give us a spatial terminology here, quantile. Okay, so decile, quantile, they are the spatial percentile here. You see that? Okay, so let me see. Those example here, I don't require that. You probably don't need to worry about this one here. No homework exam for that. It's actually based on this decile, quantile to do a further exercise. But I value more in terms of the previous example here. Okay, so no worries for this one. Okay, now one more part I want to cover tonight here is the outlier. So intuitively, right, this word here, I would say most of you have a better English, right, understanding than me, right? Outlier means what? To me, that means it's noisy, right? Something that is not normal like that. Is that right? So in statistics, we say those are the data points that is either you have like extremely high value or extremely low value. Okay. So like sometimes when you type a number, you have like a fat finger, you have like one more digit like that, right? That put the number is not in the same scale, right? Like those cases, right? Consider as a noise. So the question is like, how do we really define that when we say like extremely high or extremely low, right? So here we provided one way to do that, everybody. It turns out this way here is not the best way. Let me put it that way, okay? If you study more statistics, there is actually a much better, more rigorous way to define outlier, okay? So right now, as long as you understand what's the meaning of outlier, that's good enough. I don't require you to see using the formula provided here to find out what's the outlier for this data sequence. I don't require that, okay? I don't require that because these two formula here is way more simple, let me put it that way. So if you study more statistics, you will not use this anymore. Okay, let me put it that way. So as long as you understand outlier means what? Means like some mistake in the data, right? Some noisy in the data. It's not the clean data. So you want to clean up those before you do some analysis, right? That's what we call outlier. Okay, so that's all I planned